Hi everyone, welcome back to my YouTube channel, and this is the third problem of today's lead code weekly 362. Okay, so we can discuss this thing. Okay, so the problem is that you are given you are given a 3 into 3 matrix, and the matrix is contain exactly 9 stone. I mean, yeah, like matrix is contain exactly 9 stone, and there can be multiple stone present in the single cell. So see, in this cell the two stone is present, and this cell zero stone is present. So if you sum up all the element in the matrix 3 into 3, then the total sum will be 9. Yeah, and so in one move you can move the single stone from its current cell to any other cell if that two cells are shared a side. So I mean, you can move a stone from one cell to another cell. Okay, so and you can, okay, so in one move you can move one stone from its current cell to any one of the adjacent cell. When adjacent cells that share a side, that means from this cell to this cell, or this cell, or this cell, or in below, if any cells present, if any cell present. Okay, so this was the problem. I mean, yeah, like you can move a stone from this place to this place. This is in for any one of the place in four direction, right? And you have to tell the what is the minimum number of moves, so that all the uh, all cell contain one. I mean, each stone present in one stone in each cell. Okay, and yeah, like each cell present one stone, same thing. So what is the minimum number of moves required to do this? So this was the problem statement basically. So you have to remove some stone from this place to this place, this place, this place, so that the grid will contain, I mean, all the cells in the grid, uh, I mean, each cell in the grid contain exactly one stone. I mean, the moves are like, from one move you can move stone from this cell to this cell. This is called one move. And from this move, so I mean, for this two, so what is the minimum number of moves required? I mean, obviously, like you can go this way, or you can go this way. This is the minimum number of moves. I mean, from this place to this place, this is one, this is two, this is two. So three, in this case three. Sure, see, answer is three. And for this case, so just move one stone from this to this. Okay, this will take one move. And I mean, देखो, I mean, see, so यहाँ, I mean, here three stones are there, and we have to move two stone from there. I mean, we have to move two stone from this place to any any four cell, any two cell out of this four cell. Okay, so we just have to move two stone from here and place those two stone in two place out of this four place, right? So for that, I mean, uh, here we have two extra stone, let's suppose, and this stone can be go this place, can be go to this place, this place, this place. So we have four possible, right? And similarly for this, I mean, after placing one thing, then we have three possible way. Okay, so let's just go to this place, let's just go to this place. So for that, remove two cell and place this one, place this place. So this is two. And similarly for remove two stone, place one stone here, place one stone here, two. So total four moves. Okay, so yeah, like this might be seem like, okay, BFS DFS kind of thing, but yeah, like I think it can be possible BFS DFS, or like for that I think Dijkstra will work here. I mean, yeah, like the best solution is that Dijkstra, I think, but I did not use Dijkstra algorithm. But what I used is I just do the brute force manner, because the constant is pretty easy. Like if you see the, like, what is the, like the maximum number of cell here is 9. So yeah, like uh, the, this is the main thing. Like we can even run the brute force solution. And I think, yeah, like I just have to explain the about the constant. Okay, so how we gonna solve this using brute force? So see, if we have 5 cell, 5 0, just focus on the 0, right? Let me change the color of the pencil. Just focus on what? 0. I have 5 0. Let's suppose I have 5 0. Then 4 cell is filled. 4 cell has filled. So for each 0, I mean this how the 4 cells are filled. That is also a point. But let's just say that the 4 cell is like in this way. Mm, 5 cell is 0 there. So 4 cell. So each cell, one cell contain 2, one cell contain 2, one cell contain 2. Oh, sorry. 2 2 is 4 here. Okay, yeah. 2 1 1 3, yeah. And another cell contain 3 3 2, yeah. So these are the 4 cell, and this is the number of 0, and the remaining 4 cell are like this. So for 1 0 we have 4 possibility. 4 possibility means I can fill that 0 by taking stone from this cell, the cell contain 2. I mean obviously this is one of the cell that contain 2 element, and also this is another cell that contain 2 stone, and this is another cell that contain 2 stone, and this is also another cell that contains 3 stone. So now I just have to fill this 5 cell and 5 zeros. So for fast 0, just imagine, like just imagine case of like the fast 0. So I can fill that place by taking element from out of this in out of any one of the cell, out of this 4 cell, right? So for that, like the number of possibilities is that 4. Let's just okay, so we took this element, right? Now now this is reduced to 4. So, and for 4, now also again we have 4 possibility. So again do 4, just to reduce this thing. And now for this I mean, yeah, like take out 1 0. Okay, so for that 0 again we have 3 possibility. This is reduced to 2. Okay, and this one. And now we have 2 possibility. Now this is 1. Now I have single possible solution. So what is the number of person? 4 into 4 16. 16 into 2 32, 32 into 3, so this is 96. See, this is the total number of operation, 96. And also even you can see that like the total number of operation, similarly here I just explained this case, like we have 5 zeros and we have, like this is the worst case. What is the different number of possibility? And since the number, like total number of cell is 9, so if you try out some other possibility, then you just also feel that like this is even not exceed 1000, right? So brute force can work surely. I mean we can take another example for the better understanding. The another example can be, let's just take about see, if you're thinking like, bro, you are just multiplying 8 9, but if the 8 zeros are there, then uh, there is one single cell, and that single cell will contain 9. And for every 0 we have only single option. So we just have to find, like for every cell we just have single operation. I mean 1 into 1 into 1, that is 8. Total number of operation is 8. Here the total number of operation is 96. I think are you guys getting my point or not? Like you guys getting my point or not? So this is the thing. I mean you can run the brute force solution. This is like kind of, I think, finding all permutation. I think if you have solved this problem, finding all the permutation, how we gonna find all the permutation? So yeah, like this is kind of same problem. So yeah, like let's just discuss the solution what I did. Okay, so here I just find the yeah, like after this is you can implement on your own. This is like just do the recursive solution, because for every 0 you have how many number of possible. That is the thing, and just run every cases. Just find the minimum value. So here I found the 0. This will indicate that what is the position of the element. I mean, yeah, like what is the position of position in the grid, that cell, I mean the position of the cell. So uh, that cell contains 0, right? And this pair, what is this pair indicate? That pair indicate that the value in the cell, if what is the value in the cell, like if the value in the cell, given cell is greater than equal to 1, then I just took that cell, because I have to take some stone from that cell and to place in another cell. So that is the thing. Like here, if the value is greater than 1, then just value minus 1, because I have this many stone, and I can I'm going to replace this 10 with some other 0 in other cells, and this is the position of this thing. And if this is 0, then this is the position of thing. I think this is I think this is like understandable. So now this is the size of the 0, and this is the size of the this, and 0 and 0 and more. So this is the size of the 0 vector, and this is more vector, and this is 0, and this is the index starting point. Okay, so after that, if the index is 0, then this is the thing. And let's just suppose I have this many number. See, this is 0, this is what more. So for this 0, I can take element from this three place. So I did this thing. I just for 0, this 0 will indicate that ind. I take out the values 0 dot ind, the position, and then I did for every possible every possible cell from this more, right? So this is like okay. So after that, um, after that, yeah, like see, so if the value is present, I mean if we have some value, like I can replace this value with some other value.